And the midpoint formula is the formula to find the midpoint of a segment. So in this case, your midpoint is always an ordered pair. So essentially, you're going to find the average of your x's and the average of your y's. So you're going to say x1, x2, all divided by 2, meaning you add both x's and divide them by 2, the number of total x's, comma, your y term is going to be y1 plus y2 over 2. And that will be your ordered pair. So for our first problem here, you're told m is the midpoint of xy. Find the coordinates of y when m is negative 4, 7, and x is 9, negative 3. So the first thing you'll want to do is go ahead and draw that line segment. So if we have a line segment and we label this x, this y, and then we have our midpoint in the middle. And you know that xm is congruent to my. So we know that x is going to be some type of ordered pair. Your midpoint, m, we already know it this time, negative 4, 7. And then your coordinate for y is, or they told us x was 9, negative 3. We don't know y. We know y is going to be some ordered pair. Okay? Now, typically, if you're given the two endpoints and told to find the midpoint, you would plug them in here. You would label your points again, just like we did the last time with distance formula. x1, y1, x2, y2. You could plug it into the formula and solve for the midpoint. You could do it again in this case and do it in reverse. However, there's a simpler way. We can take, if you know that xm is congruent to my, then you can say, well, from x1 to the x of our midpoint, from 9 to negative 4, we subtracted 13. So then that means that from negative 4 to x2, or the x of our y, we're also going to subtract 13. So negative 4 minus 13 is negative 17. Okay? We do the same thing with the y's. From negative 3 to 7, we know we added 10. So from 7 to the y2, the y of our y value, we're going to add 10. 7 plus 10 is 17. So your y coordinate is negative 17, comma, 17. And that would be your answer. You could check this by plugging x and y back into the midpoint formula and solving for m, and you should end up with negative 4, 7. For our second example, we want to find a point that is 1/4 of the way from 6 to 8. So, in order to go only 1/4 of the way, when you're finding a midpoint, you're going halfway. Well, to go 1/4 of the way, what you're going to do is you're going to take, for your x value, you'll take where you start. So you take your starting place, and then you add, we're only going 1/4 of the way, so I'm going to add 1/4 of the length that I'm going to go. And so that would be your x term. And then comma, we'll just go ahead and put that in brackets so you can see all of that together. When you solve that, will be your x term. Your y term will be your starting y value plus 1/4 of the length of your y's. Okay, so we know this is our x, this is our y. In this case, we have x1, y1, x2, y2. Okay, well, we know we are starting with x1, so our x value starts at 6. We're adding 1/4 of the length is going to be your x2 minus x1, which will be 12 minus 6. Because you know that when you're finding length, it's going to be that distance. So 12 minus 6, you know that from 6 to 12, you're going 6 units. 12 minus 6 will tell you that. And so this right here will give you your x value, comma, your starting y value is 8. So you take 8 plus 1/4 of your length, and your length for y is going to be y2 minus y1, so 20 minus 8. Okay, so from here we know we have 6 plus 1/4 of 12 minus 6 is 6, comma 8 plus 1/4 of 20 minus 8 is 12. So 6 plus 6 over 4 is going to be 3 over 2, comma 8 plus 1/4 of 12 is just 3. Okay, so over here we can find a common denominator. You know 6, if you get a common denominator, is 12 over 2 plus 3 over 2, because I multiplied 6 by 2 over 2, and we have 15 over 2. Okay, so our x value is 15 over 2, and our y value is 8 plus 3 is 11. So that would be your point 1/4 of the way from 6/8 to 12/20. Oops, 1/4 from 6/8, okay? Now 1/4 of the way from 12/20 would be different. So that would be our answer. You could also call that 7.5, 11, but improper fractions will be better. And from here, we're going to talk about three-dimensional midpoint, just like we did distance yesterday. So we know three-dimensional has 3 dimensions: the x-axis, the y-axis, and the z-axis. Again, the x-axis goes left and right. That's your x. Your y-axis goes up and down. And then your z-axis goes forward to back. And so we draw that as a diagonal. This would be your z, and it shows forward to back dimensions. So from here, if you're finding the midpoint in 3 dimensions, it's no different. You're still going to use the same midpoint formula, except for now it has a z category. So we'll label our points x1, y1, z1, x2, y2, z2, okay? And we just plug it into our formula. So our midpoint would be x1 is 0 plus x2 is 12, almost that's a 0, all over 2, comma, our y's are 9 plus 1 over 2, our z's are 5 minus 3, and I did minus because it's plus a negative, which is the same thing as minus, over 2. So our midpoint is now 12 over 2 is 6, 9 plus 1 is 10, over 2 is 5, 5 minus 3 is 2, over 2 is 1. Okay, that's how you find the midpoint. Very simple. And we're done.